I'm going to show you how to write an inversion filter in C code. Now, this is actually on GitLab right here at GitLab, man, I can't fucking talk here. GitLab.com/kanjicoder/IMG 2024, right? Because the library was established in 2024. So if you want to use this code for whatever your purposes are in C, you can do that. Okay, let's go look at the source code. So this is the function belonging to image 2024. It is filter number 2, and it is our invert image filter. Invert and then I for image. Before we look at all this boilerplate, let's just look at the core algorithm, right? So the core algorithm right here, all we're doing is grabbing the red, green, and blue bytes, flipping them around by subtracting them from 255, and then putting them back where we got them from memory. And then for the alpha channel, we're actually doing absolutely nothing. So we could actually delete this line, but I want to keep this line here just for clarity of what we're doing, right? There's 4 bytes per pixel. Okay, so now that we've kind of explained the basics of this, why don't we go into a little bit more depth in case this still doesn't make sense to you. So first of all, pix stands for pixel array, and it's a unsigned 8-bit integer array. And we see that we're getting it from this general settings argument, member variable pixels. Okay, so why is there offset 0, 1, 2, and 3? Why is that going on there, right? Well, there's 4 bytes per pixel, and pixels are actually stored as collections of loose bytes. You think it would make more sense to store like individual uint32s, like 1 uint32 per pixel, but that's not the way graphics hardware works. That's not optimized for graphics hardware. Okay, so from the base address of our pixel, the red component byte, we can offset by 0, 1, 2, or 3 to get the red, green, blue, or alpha byte of our pixel, right? That's what's going on here. So 0xFF is the maximum byte value for a color channel, also known as 255. Right? So we're just taking this and we're flipping it around, right? But we're not flipping around alpha because it didn't really make sense to invert alpha. All right, so if we want to get into a little bit more detail and look at more of this crazy boilerplate, once we get far enough into these videos, I won't explain the boilerplate as much, but let's explain the boilerplate, okay? So first of all, how are we getting this byte base address of our pixel? How is that happening? Well, we see there's a little formula here, and we see there's an x and a y here. So let's look at the x and y first. So y with the underscores is for the y pixel coordinate of our pixel. X with underscores is for the x coordinate of our pixel. And the loop is in an inclusive selection area, right? So y goes from the y minimum to the y maximum inclusive, looping forward. X goes from the x minimum to the x maximum inclusive, looping forward. And y is on the outside, x is on the inside, because we want to go in scanline order here for efficiency. So we go to the next row of data, every single pixel in that row. Go to the next row of data, every single pixel in that row. Okay, so this XY loop should make sense, right? And because this loop, I know a lot of people will like indent after every single loop, but I think of this as kind of like one thing, right? It's a doubly nested loop where we're looping through the X and Y, right? So I stack them right next to each other, and then I close them off right here, right? And I say next X and Y. I got the next convention from writing way too much Visual Basic code as a kid. I didn't pronounce that very well, enunciate. Visual Basic. I wrote too much of it as a kid. All right, so we know we're looping through the X and Y selection area of a larger image, but we need to convert that XY pixel address into this byte address eventually, right? C is for component, by the way, right? The red component, the green component, the blue component, and the alpha component. Okay, so what are we going to do? Well, we need to use this formula to get the one-dimensional address of our pixel, the pixel index, and then we need to multiply that pixel index by 4 because there's 4 bytes per pixel. So let's look at this formula right here. What's going on here? If all of our data for our pixel array is in a big one-dimensional array, the convention is to stack all of that data in scanline order. So we stack all the data points from left to right, top to bottom. And if we want to pull something out and get its like, so we have the XY coordinate here, right? This index is like, this is like the one-dimensional coordinate of the pixel. This is the two-dimensional coordinate of the pixel, X and Y, right? So every single time you go down a row, you've filled an entire row of pixels, right? So what the y-axis value actually means is how many filled rows of pixels you have, right? And the x-axis value actually means how far into the base address of the current row are you, right? So y times width, the width of the image, aka how many filled rows of pixels do we have, right? So if y is 1, we have one filled row of pixels above us in the y equals 0 row. And so y times width, because the number of pixels per row. I don't know, you know, I'm not explaining this very well, am I? Am I? You know, maybe I'm getting into too much depth. Let's try this again. So if I was to concisely explain this, right? The number of filled rows times the number of pixels per row gives us the base address of the current row of pixels we're on. And then we want to add x to seek into that base address. And once we've seeked into the base address by x from this base address here, we get the one-dimensional pixel index. Okay? And so this is actually the index. If we were storing a one-dimensional array of uint 32s instead of loose bytes, we would be done here, right? But we have to multiply that index by 4 because there's 4 bytes per pixel, and each byte is stacked right next to each other, right? So the color format is RGBA, 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 right? Oh boy, okay, I feel like I could do a better job here, but, you know, I don't want this to take all fucking day. Alright, so, what do we have right here? So, we have this loop where we're going through an inclusive selection area, and we get that inclusive selection area from this gen variable, which stands for general arguments. This general variable is a pointer, so we have to access the member variables with a arrow operator to say that we are dereferencing the memory address here and getting the... Sorry, that's not what we're doing. We're dereferencing this memory address and then getting this property, right? And so this C code is complicated. Because this is a memory address and not an actual value, you have to use the arrow key, and the arrow key is basically telling you that to get the property of this, we first have to dereference it to get the actual object, and then access the property. I feel like maybe I shouldn't be explaining how C code works here. Like, maybe I should just be explaining the algorithms, and then... if you don't know enough C code, then maybe this isn't for you. I don't know! I don't know what I'm doing! Alright. So... member variables. All of my member variables for all of my structs are going to start with the M underscore so that I can just look at this and immediately know that it's a member variable of a struct. We have X minimum left boundary inclusive, the X maximum right boundary inclusive, the Y minimum top boundary inclusive, Y maximum boundary inclusive, right? So 0 for minimum, 1 for maximum, X for x-axis, Y for y-axis, and then L, R, T, and B for left, right, top, and bottom inclusive edges, right? Now we can shorten that to just x0, x1, y0, and y1. So a little bit of linear algebra kind of notation. Okay, so this is basically extracting the boundaries of our loop from our general settings object, and this is extracting the raw pixel array from our general settings object. In this specific function, we don't actually need to use the height. That's why this line is commented out. The width, we do need the width. We always need the width because we need to eventually convert the xy coordinate into a one-dimensional index I. And then here's a whole bunch of other variables that we just declared in all one line because, you know, this already takes up a lot of space and it's all boilerplate code, right? So the x pixel address, the y pixel address, the pixel index, the component address of the red byte of our pixel or the first byte of our pixel, the left, right, top, and bottom boundaries. This is just a little thing to make sure that my compiler doesn't complain if I don't use this arguments object. This is a helper function that gives me back the original input arguments object if this is non-null, and gives me a default configured arguments object if this is null by using the filter number here. And this is a function that just does some error checking on the general argument struct that gets passed in before just piping it back down here and just reassigning it to gen without I_gen, just to make things a little bit terser. So right here, function belonging to the image 2024 library, filter number 2, and then the inverted filter. So we have the pointer to the general arguments that all filters take as their first parameter. We have argument 2, arg type 2, which is for filter 2, and it's NOK for nil OK arguments. And then we have a uint32 type, which should be either a 0 or a 2. A 2 because this is filter number 2. So I explained this in the previous video, but the basic idea is that I don't like Java code, okay? I do not like Java code, and I don't like how people who write Java like to, like, throw in null checks all over the fucking place, and they think it's acceptable for something to be null. I don't actually think it's acceptable for things to be null, and so if you are passing around null, you need to be really fucking careful with that. So we don't just want to pass in, like, general arguments and nil OK arguments and just call it a day, right? And then if this is null, we do something, right? And we have to do a null check. Yes, we're going to do a null check, but we don't want to accidentally, like, pass in null by accident, right? So this right here serves as redundancy to make sure that if this is null, we meant to have it null, and if it's non-null, we meant to have it non-null. So, for example, if this is non-null, then this value is going to be 0. And if this is null, this value here is going to be 2, right? And then we're going to use this helper function right here, which is going to make sure that the combination is correct, right? So if these are both 0 and 0, right, address 0 and value 0, that's going to crash. If this is a non-null address, a non-zero address, and this is also a non-zero value, then this function is also going to crash. Now, if this is non-null and this is 0, then this value just gets piped into here. If this value is null and this value is 2, we're going to use that 2 to grab a default configured arguments object type 2 from a lookup table. And then we're going to grab that from a lookup table and then pipe it into here, right? So this is basically just some boilerplate code to make sure that we have all our ducks in a row, right? There's a lot more that I could get into, but we are already like 13 minutes in. The previous video, I went into more detail about the architecture of this, because, right, there's a lot of boilerplate here, right? To just write a simple algorithm, it wouldn't be that hard, right? The reason that there's so much code here is because eventually what I want to do with this library is write a some type of application where you could, like, batch process images and have a text file where you just select a whole bunch of different filters that you want to execute on every single image, and then just it batch processes it for you, and that would be cool, right? What else do I have to say? I don't know, why don't we go dig into this a little bit more? So we're done. You can leave now, but let's dig into this a little bit more. So we have this function right here, and I'm telling you that this function is being called, right? But we know that that's not the actual function that we're calling here, right? So there's a lot of indirection to get from here to the function we were just looking at. Now, you can say, well, if this is supposed to be the easy code, then why is there so much indirection? Well, the easy namespace means that it's easy to use from an API standpoint. We just have to call it, right? We don't have to worry about what arguments to supply it with, right? Because you notice that the function that we're looking at took 3 different arguments that we have to get from somewhere, right? That's a lot of extra configuration, right? I don't want to have to think about that when we're just trying to get something up and running on the screen, right? So let's look at the code and figure out how we get from here to the function we were just looking at. So let's grab onto this. Let's go Control F, and let's just go search around for references to this function and just see what happens. Okay, so we see right here we have easypng2, and it's wrapping a function called easypngdex, and it's doing it with the 2 here, right? Now, this feels really ugly and clunky. Like, I feel like there might be a more elegant way to do it. But you know what? This isn't too bad, right? Yes, it is very redundant and very cut-paste-ish, and that should be a 4. It is very redundant and very cut-paste-ish, but it's very dead simple. It's stupid simple. You know what it means, right? Okay, so filter number 2 is our inversion filter. That's why there's a 2 here. And we're going to call this easypngdex function with a 2, which, if you're looking at this, it probably makes sense that we're about to use a lookup table to grab the actual function and call it. And not only do we want to grab the actual function and call it, but we also want to make sure that we get the correct configuration objects and whatnot, and the correct references to the actual pixel memory that we want to start applying the filter to. Okay, so now that we see this right here, why don't we go search for where this is declared? Now, because we are writing our C code with 0 forward declarations, that means that the declaration site to a function call is always going to be further up the file and never further down the file, because we're not using any forward declarations. And that's nice, because that means it's very easy to find things without any fancy tools or fancy editors or IDEs or whatnot, right? I'm just using plain Notepad++. That's as complicated as I need to be. So what I'm going to do is I'm going to go grab onto this function name, and we're just going to search for that function name. We're going to search in a backwards direction, and we're not going to wrap around. Now, if we just search backwards, the last reference as we go up the file is going to be the actual declaration, right? This is the last reference right here, and it's the declaration. So let's go see what this does. So it returns void, and this is just a macro for void. I'm a little bit OCD here, so all of my type macros are going to be like 3 letters in all capital, but hopefully VOD for void makes sense here. Function belonging to the image 2024 library, easypng namespace, index. So this is a function that takes a index. Here's our index. It's an input, and this index is a uint32 because this index actually corresponds to the filter type index. All right, so we looked at this in the previous video. Like I said, you can leave now. We already explained the filter. You can leave. I'm just explaining more of the architecture. And we'll stop explaining the architecture once we get into, like, really complicated filters to where it's like, you know, the filter's so complex that we don't have time to get into this other stuff, right? Okay, so what do we have here? So we have another macro here, and it's called GVT. So GVT pointer equals GVT variable, and we're getting this GVT variable from a vtable. Why do I know it's a vtable? Because v underscore stands for vtable. What is a vtable? A vtable is just a fancy, pretentious way to say it's a lookup table of functions. Okay, so it's a lookup table of functions, a vtable, belonging to the image 2024 library, belonging to the easypng subnamespace, and this lookup table desires an index to be put into it in order to get out whatever we need to get out, right? Okay, so now that I know that, the next thing is, well, what's GVT here, right? So if we highlight this, we can see there's a whole bunch of GVTs here, and I try to keep my, like, really terse macros, like, close to wherever they're being used, and we see define GVT. GVT is a function belonging to the image 2024 library, a function that takes a general arguments for a filter, a void pointer, and then a uint32 describing the type of filter that we're executing. So this is a function type, not a function pointer type. And the reason I use function types rather than function pointer types is because then when you have a function pointer, it reads more like a function pointer than it would otherwise if the pointer was embedded into the type def. Okay, so any function is the equivalent of a void pointer, but you are not allowed to mix data pointers and function pointers in C code. So when you have very strict compilation, you can't just like cast a void pointer to a function. You're not allowed to do that. So if we want to take these functions and we want to recast them to this type here, we have to first take this and we have to downcast it to basically a any function pointer, and then upcast it to this function pointer type. So all functions take 3 arguments. They take a general settings object, a specific settings object that is unique to that filter, and a uint32 that tells us what type it has. So if we want to pack all of these functions into an array, well, then all these functions have to have the exact same prototype, the exact same signature. And all these functions actually have slightly different signatures because the middle parameter is a configuration object specific to that function. And that's why we have to take that specific configuration object that is the middle parameter, and we have to just say, oh, you're no longer a specific configuration object, you're just a void pointer, right? You're just a wildcard, right? So general arguments, a void pointer, that's a wildcard to the specific configuration arguments of our filter function, and then a uint32 that describes what type of filter we have. Okay, so this is our lookup table of functions, right? So function belonging to the image 2024 library, filters 0 through 9, and if we haven't actually written a filter for the code yet, we'll give it unknown, right? Right now, we are reviewing the inverter filter, which is right here, invert, and then I for image, right? And then we've already written a blur filter and a halftone filter, or halftone filter. I'm calling it halftone. Yes, I'm very OCD. They're exactly 7 letters. Sue me. All right. So now that we see this lookup table here, and we see this inverter filter, hey, isn't that what we wanted to look for? Let's go grab onto this. So Control F, we're going to search backwards for the reference to this. Remember, we never use any forward declarations, so when you see a reference to something, you always know that it's defined further up the file. So let's go find next, searching backwards. And we find the end of the function section for our filter. We see the core logic that we were looking at earlier. And then if we scroll up here, we see the declaration of the function right here. Function belonging to image 2024, filter number 2. It's the inverter filter, right? So hopefully that kind of makes sense. All this code is being put into one file. And I think I'm going to start to make like a function index here. To just keep like a summary of what's here. Now, I don't use forward declarations in my code, and because of that, a header file, well, first of all, I don't really want this to be, I don't want to break this up into 2 different files. Well, that technically it's already broken up into other files, because we have the dependency on the load PNG library. But basically, I like to keep things in very... I find when I make projects, the projects get very big. And I try to avoid having too many scattered small files all over the place. So I try to make sure that like every little subsystem is like a huge file, right? Which seems kind of ridiculous. But, you know, when you have a really large engine, I just cannot manage like a whole bunch of small files. I will lose track of where certain things are. So I like to have these kind of like monolithic files for different responsibilities, right? So this subsystem image 2024 is a image processing system, a larger game library I'm working on. But all the code is going to be pretty much isolated to this one file so that it's very easy to pass around, send to people, zip up, send it to someone, right? Anyways, I'm ranting. The point is that since I'm not using forward declarations, if I want to create kind of a header of sorts, right? Because a header file isn't just for forward declarations. A header file is also like a nice summary of like what's in your file, right? So what we might want to do here is just like, oh, this is example function And this isn't actually right. Do nothing example. Oh no, that's actually right. Macro function, do nothing example function. Okay, I see what I'm doing here. So I'm making kind of like a macro, and I'm using kind of a naming convention that I wouldn't actually use in my code, just so that if you want to call it like this, you can, because I know that the way I write code is kind of weird, and so I'm trying to make it a little less weird. You know what, maybe what we should do is we should just create a settings struct of some sort. But if we're not using any forward declarations, the settings struct would have to go after the actual definitions of the functions. All right. Do we want to, like, maintain this index? I guess. Let's maintain this index. Let's do that right now. So, image 2024 nothing. That's not actually the function name, is it? That's a monkey wrench now, isn't it? Yeah, that doesn't actually go anywhere. So, that doesn't actually go anywhere. Macro functions, air macro is a function, message is a function, macro types. Well, what do we want to do here? Let's get rid of that. Let's just get rid of that. And we have this index right here. But it's actually kind of far down, right? I mean, it's not too far down. Like, maybe this index should go at the top of the file, right? Let's move this around. Let's move this around a little bit. I think this index actually makes more sense at the top of the file, right? And then I think that maybe even these prefixes that kind of explain the different naming convention, I think that actually probably belongs more at the top of the file as well, right? Like, how do things work around here, right? Now, if we're going to move those around, right, the prefixes section and the index section, then we need to have that reflected here. So here's the prefixes section, here's the index section. Why don't we go put that up here like that, all right? So we have about, we have the index, so this is self-referential, we have the prefixes explanation, macro functions, macro types, and then like a whole bunch of other subsections, right? So what I'm doing here is I'm kind of making like a text-based user interface, right? Like, we can use these as like hyperlinks, right? I can go grab onto, say, this vtable section, I can go Control F, and it'll bring me to, or it won't! My god! Okay, well we have to go figure out why that's not that. Oh, because we're not wrapping around, and we're searching backwards. Okay, now let's do it. So it brings us to the vtable section, where we have our vtable, and the vtable section is pretty small, and if we find next, we end up back here, right? We have some code that we stole from a library we wrote years ago to do the file saving and loading. We have the main function section. We have the easy PNG subnamespace, because the easy PNG subnamespace seems like it's going to get kind of big. Yeah, the easy PNG subnamespace is getting kind of big. So it got its own section of the file. There's test code, right? Undefs. There's a lot of stuff in here. I am so wandering around here. I'm not very focused. We already covered the filter. We're 28 minutes in. I think we should just end this. Should we just end this? Oh, wait, we didn't run the code. Did we not run the code? We didn't run the code. Let's show you how to run the code. Let's show you how to run... Oh, my God, I didn't show you how to run the code. Okay. So, let's go... Okay. So there's like an let's show... Okay. Right-click Git Bash here. Let's go open up this terminal here. You know, we could keep on trying and trying to make things perfect here. But I think that through repetition, through, trying to make these videos over and over again, we'll get better quality as we go, Or maybe we won't. Maybe we won't. Maybe I'm just going to rant like an insane, unfocused person all the time, every single time I do this. And it's just going to be a bad time for everyone, right? So, first of all here, we really should... have something where we so you can't see the very top of my terminal, right? Maybe that's not the best idea, right? Maybe we need to work on our goddamn presentation a bit. Let's just do that. Let's do this for now. Let's just do this for now, right? Okay, so let's do ls for a second, see what's in here. Okay, so we see some images, and we see our source code, and then we see another file with the exact same name as our source code, but it's .sh rather than .c11. So .sh stands for shell. It's a shell script, and it's a shell script that's going to build and run our project. And the terminal I'm using is the git bash terminal, the minty terminal, the mysys2 or msys2 terminal, whatever you want to call it. Let's go do this now. So /image2024.sh. So if we do that, we can execute this. Now, if you're in a batch file, you don't have to do the // but in a shell script terminal, usually you have to do the // otherwise it's not going to execute. All right, so we see some logging messages from the image 2024 C11 library. Forever Alone compile. We're touching the file cat4.png. And then it says that we are saving the file and that we're exiting. Now, between this point and this point, we should be running a filter. And why are we saving cat4? Ooh, that's bad. Okay, let's go look at our code. Did I screw that up? God damn it, I screwed that up. So I was kind of like refactoring this midstream. And now we just overwrote cat4 with cat2. God damn it. Well, let's go look at that, right? So cat2 is our inverted thing, and now cat4 is also inverted. Let's go look at our cats. So here's the original cat. Here's the do nothing filter. Here's the inversion filter. And then here is a blur filter that will show you how this works in the next video. And then this is actually not supposed to be a, that's not supposed to be that. Let's go put the code back how it used to be, I guess. So because we're working ahead, that's why we're shooting ourselves in the foot. Let's put that back to a 4, right? And show you the most recent filter that I've been working on. Because the most recent filter is kind of interesting. We'll get into the logic for that filter in the video actually dedicated to filter 4, because right now we're on the filter 2 video. All right, so let's go, just hit enter, let's clear. Let's go up arrow until we find that again. Let's hit enter. And let's go check out what cat4.png looks like now. Let's go grab that. Let's go. All right, so we have cat0, we got cat1, the do nothing filter. We have cat2, the inversion filter. We have cat3, blur filter, and we have cat4, which is a what is it called, a halftone filter? Halftone. It's called a halftone filter. Well, it's my own take on a halftone filter. Anyways, we'll tell you how this filter here works in another video. It's pretty cool. Hopefully what we're going to do is we're going to make more and more interesting filters, right? We're starting out with very simple filters, right? Inversion and blur, and then getting into more complicated things after that, because right now the kind of like code in which these filter algorithms exist, the whole containing code, the framework in which the code exists, is a little bit complicated. So I figured we'd start with some simple filters, just so that we can get our feet wet and understand some of the crazy-ass code around here. All right, so now that we've kind of like mucked around and we've executed the code, we know it compiles, and we've, you know, shifted some of this index around and cleaned some things up, we should probably commit our changes. So why don't we go over here, and let's go clear, and let's do a git add dot, just add everything, clear, git status, and we have some new files. Let's go git commit all of those and say filming filter video 2, right? We're in the middle of filming filter video 2, so we'll make that our commit message. All right, cool. And then let's go push this up to our remotes. Let's go git remote -v for verbose. We have a GitLab remote. We're gonna push up to GitLab. So let's do that. And these remotes are not actually the remotes for the public version, because what we're looking at right now is the source code as part of a larger game engine, and the game engine is my private personal game engine that I'm working on in C code. But I'm going to let other people use this module because I find this module very useful and figure that it could be useful for making content for my channel. Anyways, so let's go git push git lab master. Okay, so let's go push that up, and it's going to ask us to sign in using the browser because I'm not using SSH keys right now. Let's go sign in with our browser by clicking that button. It's going to open the evil Internet Explorer or Edge or whatever it's called these days. Same shit, different name. And why the fuck don't you remember me? Okay, so to make sure that I don't accidentally show my password, I'm going to type this up on my top monitor. All right. Boom, boom, boom. Boom, boom, boom. All right. And then I'm going to sign in and hope that I typed everything correctly. I did. Cool. So now we're going to hit authorize right here. And then we can close this. So let's close that. All right. So it's pushing everything up. And now that is up on my private repo. But we want to get this up on the public repo right here at gitlab.com/kanjicoder/image2024. So what we're going to do here is we're going to take... Okay, yeah, we can keep those here. We're going to take all of this stuff here. We're going to take all of it that's in this image 2024 library. We're going to take it all. We're going to copy it. And we're going to go open up our public version, our public mirrored version of this. So let's go into our Git repos folder and find the image 2024 library. So this is the public version. And I'm going to make sure that the public version is up to date with my game engine right now. We're going to go paste everything, and we're just going to replace everything. Yep, we're just going to replace everything. Replace the files. There we go. All right. So that all looks good. Let's go into the documentation. That looks good. Dependencies. That looks good. Okay. Let's go right-click. Let's go git bash here. And then what we're going to do here is let's just make this a little bit bigger. And then we'll zoom in here. We're going to go git status. All right, we have some files. Let's go git add dot, clear, git commit -m. And I'm just going to say filming. I don't know. Filming filter video 002 inversion, right? All right, there we go. Clear, and then we're gonna git push git lab master. And that remote here, even though it's the same exact name, it should be pushing up to a different remote. All right, so let's go sign in with our browser. And I swear to God, if it asks me to enter my password, what the fuck? Did I not click the remember me? It's like, oh, I see you closed Edge. We're going to totally delete your fucking session. One more reason not to have Edge as your default browser, but Edge always likes to fucking hijack your browser settings, right? Like, I don't fucking use Edge ever, but, you know, you always, like, accidentally install something, and it sneakily is like, haha, I've taken control because you installed some piece of shit software that has malware in it, or some other shitty fucking practice. So, let's see. Okay, I think I got that. Let's go sign in. Okay, so now I'm going to press this authorize button right here. And then we're going to close that. And okay, it's pushing up. Good. So now I'm going to close this because I don't want to accidentally work in this directory because this is like a mirror repo. So I'm going to close this so that when I'm doing work later today, I don't accidentally fuck that up. All right. So if you want to use this code, it's in this repo right here. It's at gitlab.com/kanjicoder/image2024. There's the URL right there. Maybe I should make a scene where we can make that larger or something. Maybe we should do that right now. Yeah, maybe we should do that right now. Should we just fucking do it? Should we fucking do it? we already took way too much time explaining this stuff, and I don't want to do another take, and maybe we should make some steps to make the next video less shit, right? Alright, so why don't we do that? Let's go add a scene. We're gonna lose sound really quick when I do this, and I'm gonna say URL zoom. I'm gonna call it URL zoom. I'm gonna hit OK. And, oh, we still have sound over here. That's nice. I'm going to add a source. I'm going to add a display capture. We're going to go add the existing display capture. We're going to go down to our bottom monitor. And then what we're going to do here is we're going to just try to make this bigger by just kind of like cropping it a little bit. We're going to crop it a little bit. And then we are going to expand it, right? We're gonna crop and stretch, but maybe not. Maybe it's gotta hold that control button there. Yeah, there we go. So we're gonna put that there, and then do we like that? Can we crop that a little bit better? Does that feel a little bit better? Like if we cropped it like, and then control. Okay, so I think that looks a little bit better. The text is kind of... the text leaves something to be desired, but now you can see the URL right up there a little bit better. Let's go back to the main scene right here. My name is Kanji Coder. I'm making a game engine, and I'm also making a filter library that you can use in your own C code. And eventually it is going to have a batch processor where you can specify a text file and run it on a batch of images in a folder to create a gallery of photos that all have a custom, like, meta filter, right? So the idea is that if we can take all these filters and figure out different combinations to apply them to images that get, like, interesting results, we can then save that combination of filters in some type of settings file, and then we can roll through a whole bunch of files in one folder and batch process images, right? I think I've talked enough. My name is Kanji Coder. We're making filters. So hopefully that was informative. I know that was way too long for just an inversion filter, but most of this video was not the inversion filter, right? So if you are fast forwarding to the end of the video, the filter logic is like in the, first 10 minutes is the actual algorithm logic, and then everything else after that is just me going on a detour. I don't know. Let's just get out of here. My name is Kanji Coder. Like and subscribe.